Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us begin solving this step by step. We analyze each part using fundamental mechanistic principles. A. SN2 reaction rate. SN2 is favored by less steric hindrance at the electrophilic carbon. Cyclopentyl, CH2Br. The carbon-bearing Br is a primary carbon, CH2Br, with only one substituent, the cyclopentyl group. This is a primary alkyl halide, very accessible to backside attack. 1-methylcyclopentyl bromide, Br is on a tertiary carbon, the ring carbon also bearing CH3 and 2 ring carbons. Tertiary carbons are extremely hindered toward SN2. Therefore, cyclopentyl methyl bromide, the primary substrate, undergoes SN2 far more rapidly. B. E1 reaction rate. E1 proceeds via carbocation. Intermediate rate depends on carbocation stability. PHCH, CH3, CH2, CH2Br. Br is on a primary carbon, CH2Br, 3 carbons away from pH. The carbocation formed after ionization would be primary-secondary with limited stabilization. PHC, CH3, Br, CH2, CH3, Br is on a tertiary carbon that is also benzylic, directly attached to the phenyl ring and bearing CH3 and ethyl. Ionization gives a tertiary benzylic carbocation, which is highly stabilized by both the tertiary nature and resonance with the aromatic ring. Therefore, PHC, CH3, Br, CH2, CH3, 2-bromo, 2-phenylbutane undergoes E1 more rapidly. C. SN1 reaction rate. SN1 is favored by more stable carbocations upon ionization. 3-bromocyclopent 1-Na, Br at C3 vinyl double bond at C1, C2C3 is allylic to the double bond. Loss of Br gives an allylic carbocation stabilized by resonance with the double bond. This is a secondary allylic carbocation. The other isomer shown has Br at C4, labeled as the lower Br in the image, also drawn as a cyclopentene with Br further from the double bond. C4 is homoallyl or simply secondary but not allylic, no resonance stabilization of the carbocation. Therefore, 3-bromocyclopent 1-Na, allylic bromide, Br at C3, undergoes SN1 more rapidly. D. SN2 reaction rate. Again, steric accessibility is key. Both substrates are chloronorbornanes, bicyclo, 2.2.1, heptane framework. The first structure has Cl at the C7 position, the 1-carbon bridge, the methylene bridge at the top of norbornane. C7 is a secondary carbon, but it sits in an IChO-accessible position with relatively less steric crowding compared to the bridgehead adjacent endo position. The second structure has Cl at the C2 bridgehead adjacent position on the 2-carbon bridge, which is more sterically hindered within the rigid bicyclic cage. In norbornane systems, the C7 bridge methylene position allows better backside approach for SN2 than the more cage-congested C2 position. Therefore, the norbornane with Cl on the 1-carbon bridge, C7, undergoes SN2 more rapidly. E2 reaction rate. E2 requires an antiperiplanar arrangement of the H and leaving group. Both are chloronorbornanes. For the C7 chloride, 1-carbon bridge, the rigid bicyclic framework makes it geometrically very difficult to achieve the required antiperiplanar H-C-C-Cl arrangement for E2 elimination because of the bridged ring constraints at C7. For the C2 chloride, ring carbon adjacent to bridgehead. Although the norbornane framework is rigid, the C2 position can more readily achieve an antiperiplanar relationship with adjacent H atoms for E2 elimination. Therefore, the norbornane with Cl on C2 ring carbon adjacent to bridgehead undergoes E2 more rapidly. Therefore, the correct answer is A. Cyclopentylmethyl bromide, cyclopentane, CH2Br, B2 bromo 2-phenylbutane, PHC, CH3, Br, CH2CH3, C3 bromocyclopent 1Na, allylic bromide, D2-chloronorbornene, Cl on the 1-carbon bridge, C7, position, E2-chloronorbornene, Cl on a ring carbon adjacent to the bridgehead, C2. Therefore, the correct matching is A matches cyclopentylmethyl bromide, cyclopentane, CH2Br, B matches to bromo 2-phenylbutane, PHC, CH3, Br, CH2CH3, C matches 3 bromocyclopent 1-ene, allylic bromide, D matches to chloronorbornene, Cl on the 1-carbon bridge, C7, position, E matches to chloronorbornene, Cl on a ring carbon adjacent to the bridgehead, C2.